Now today we will be discussing about the flag register organization of 8086. Again, the flag register is also of the 16-bit register. Out of these 16-bit registers, 9 bits are used to signify the different flags. The 5 flags which are used in 8085, that is why it is written 8085 compatible flag. The same flag will be used in 8086 also. But besides these 5 flags, carry flag, parity flag, auxiliary carry flag, zero flag, and sign flag, we use some more flag, that is trap flag, which is also called single step trap flag, IF, that is interrupt enable flag, direction flag, which is used for the string operations, and we have an overflow flag. So let us understand the working of these additional 4 flags which are available in 8086, because as far as the working of the previous 5 flags, carry flag, parity flag, auxiliary flag, zero flag, and sign flag, is having the same meaning as it is defined in 8085. So we start with the extra flags which are available in 8086. Now let us understand the working of the overflow flag. What is the meaning of overflow? This flag is set if the result is going to be out of range. Now the meaning of the overflow is, suppose you have a glass. Glass will have its limit, its capacity. Suppose the glass can be used to fill with the liquid by 250 ml. And whenever you fill a water in the glass, up to its capacity, it will be filled. But whenever you try to fill the glass over its capacity, the water is going to overflow. It means whenever we are putting any value into a register which is out of its range, if we want to put 16-bit number in an 8-bit register, it will be going out of range because the capacity of the register is of 8-bit. And if we are putting 16-bit number into that, so only 8-bit will be stored and the rest will be over. So actually the meaning of overflow flag is because this flag is going to give the information whether it has been set or not. It is set or reset. So whenever the flag is going to set, it means the result is out of range. The result which we are getting, it is not accommodating within the register. So the meaning of overflow is it is set. This flag is going to set when there is a carry into MSB, whatever is the most significant bit. Previous to that bit, if previous bit is going to give you the carry into MSB, then the carry flag will be set. As well as this is AND is written, no carry out of the MSB. If the carry is generated from the previous MSB bit to the MSB and there is no carry generated out of MSB, then the overflow flag is going to set, or vice versa. Vice versa means if there is no carry into MSB, and there is a carry out of MSB, then it is going to set. So it means there will be 2 cases in which the overflow flag is going to set. One is whenever previous MSB bit is going to generate a carry into MSB and MSB is not going to generate any carry, or previous MSB bit is not generating carry, but MSB is generating a carry. In both the cases, overflow flag will be set. Now, this is the case of addition. In case of subtraction, it is going to set if MSB needs a borrow, while subtracting two number, if MSB, no significant bit, is in requirement of a borrow and there is no borrow from the MSB to its previous MSB bit or vice versa, that MSB does not require any borrow and there is a borrow from the pre-MSB bit from the MSB bit. So there are two conditions to set the overflow flag while doing the addition, and there are two conditions to set the overflow flag whenever there is a subtraction process. In case of addition, if there is a generation of carry from the pre-MSB bit to MSB and MSB is not generating carry. And second case is pre-MSB bit is not generating carry, but MSB bit is generating a carry. In case of subtraction, MSB requires borrow and there is no borrow from the pre-MSB bit. And MSB does not need a borrow and pre-MSB bit is in requirement of a borrow. So in both cases, overflow flag is going to set. The second flag is trap flag. This flag is used for single stepping through the program. You know, single stepping means one instruction, one by one. Normally the program used to execute as a whole. But whenever we want it to be in single stepping, the trap flag is going to give this information. If this is set, if the trap flag is set, the trap is executed after the execution of each instruction. After each instruction, there will be a trap, there will be a hindrance. That is, interrupt service routine is executed, which displays the various register and the memory content after the execution of each instruction. So meaning thereby, if this flag is set, what used to happen that after each instruction is executed in a step-by-step process, whatever is the result, it will be displayed on the screen. The result will be either in the memory or it will be in either in the register. So after each instruction is executed, trap service routine will be executing, and trap service routine will be displaying the content of the result in the form of that is the display of the register or the memory, wherever the result is. So this is the meaning of trap flag. Interrupt flag. In 8086, a facility has been provided whether any device can interrupt the processor or does not. It means until unless the interrupt flag is not enabled, no device can interrupt the process which is being function of the processor. It means if any device wants to interrupt the processing of 8086, the interrupt flag should be enabled. Otherwise, it cannot be interrupted. This facility is not available in 8085. Whenever an interrupt comes, it is unconditional. It has to be handled by the processor. But in 8086, there is a facility which is provided through the interrupt flag, because which is going to allow or it is going to prohibit the interruption of the program. If it is set, the maskable interrupts can be recognized by 8086. Otherwise, maskable interrupts will be ignored. Now, the difference between the interrupt operation which is done in 8085 and 8086 is, in case of 8085, we have 5 interrupt lines: trap, RST 7.5, 6.5, 7.5, 5.5, and INTR. In case of 8086, there is only one interrupt line, that is INTR. And this line will work only if it is enabled. means any device which wants to interrupt have the facility of interrupting the processor only through the one line, that is INTR line. So this is the meaning of interrupt flag. Then we have direction flag. Direction flag is most often used while handling the string instructions. If this direction flag is 0, the string is processed from its beginning with the first element having lowest to the highest address. Otherwise, if DF is 1, the string will be processed from the beginning with the last element from the highest to the lowest. So this is the meaning of the direction flag, which is used only for the string operation in string instructions. So these are the 4 additional flags which are used in 8086. So it is a TF is a single step trap, which is going to give the information whether the processor is working in a single step mode. Interrupt enable flag is set, then only the interruption can be done. String direction can be achieved. It will be either from the lower address, from the beginning to the end, from the lower address to the higher address, or it is from the higher address to the lower address, means from the end to the beginning. And overflow flag is out of range. So these are the 4 another flags besides carry flag, parity flag, auxiliary flag, and the 0 flag. Now let us discuss about the pointers and the index registers. We have different pointers which is working as a pointer registers: stack pointer, instruction pointer, base pointer, source index, destination index, and all these registers are 16-bit registers. And the functionality of these registers is to provide effective address or the offset address which has to be added with the segment register's base address. If we are working with the stack segment register will be giving the base address, and effective address will be given by the stack pointer. Whatever is the content of stack segment, it is shifted 4-bit left, and whatever is the content of the stack pointer is added into that, so that we are able to get the 20-bit address. Suppose stack segment contains 5000, that is a 16-bit number, and stack pointer contains FFE0. So what will happen? The physical address with which within the stack segment, the physical address will be 50000 added with FFE0, so that the address will be 5FFE0. As I told you earlier, that whatever is the content of a stack segment, it always signifies the starting of that segment. If we are talking about the stack segment and the stack segment register contains 5000, it means from 50000 to 5FFFFF will be the physical address of the stack segment of the memory. And out of this 64 kilobyte of the memory, which address we want to fetch for reading or the writing purpose, that is given by the stack pointer. And that is why this address is called effective address, and this address is called the base address. So we do manipulation in the summation device by shifting stack segment content 4-bit left, adding stack pointer into that, so that we can get the effective physical address as 5FFE0. Similarly, whenever we work with port segment, the effective address is given by the instruction pointer. as discussed earlier while discussing the instruction pointer. The content of the code segment register is shifted 4-bit left and content of instruction pointer is added so that you are able to get the physical address. Similarly, whenever we have to work with data segment, any one of these three register, base pointer, source index, and destination index, can be used to provide the effective address within the data segment. Of course, the data segment register will provide the base address, and any one of these three registers can provide the effective address. So the content of data segment will be shifted 4-bit left, and the content of BP or the SI or the DI register will be added into that to get the effective address. Now the functionality of BP, SI, and destination index, that is base pointer, source index, and the destination index. It can be used also as a general purpose register to store any 16-bit number, but their main use is to store a 16-bit offset or the effective address of the data word in any one of the segment. If we talk about the base pointer, we can use this base pointer instead of stack pointer for accessing the stack using base addressing mode. Instead of SP, BP can also work as to provide the effective address for the stack segment. Of course, the BP can provide the effective address for the data segment. It can also provide the effective address of the stack segment. So in case effective address is available in BP, we don't use SP to calculate the physical address, but we will use BP. And it will depend that what is defined in the addressing mode in the instruction. Source index can be used to hold the offset of the data word in the data segment. So the physical address is calculated with data segment as well as source index. Similarly, destination index is going to point to the extra segment in which the data is stored. So the physical address is calculated with the help of extra segment and the destination index. Besides that, we can change the identification of the effective address registers by defining the name of the registers in the instruction itself. Meaning thereby, if we have to fetch the data from the data segment, the data segment register will provide the 16-bit base address, but any one of these register, base pointer, source index, and destination index, can provide the effective address. And how it will be recognized? If any one of these names are written within the instruction. We will see certain examples with which it will be more clear. Now let us discuss about the segmentation. Why segmentation is being done? What is the advantage of doing memory segmentation in case of 8086? And what are the disadvantages of doing the memory segmentation? One of the important feature of 8086 is to use the memory in the segmented form. The first advantage of doing the segmentation is that whenever we do segmentation means to break into the parts. But whenever we break into the part, the maximum part, the size of the maximum size of any part of the memory cannot be more than 64 kilobyte. So we are working with the memory of having the capacity of 1 megabyte. But doing segmentation, it allows memory addressing capacity, address associated with each instruction as the 16-bit. Because what will happen if we divide the memory into segment, and each segment will be of 64 kilobytes, so only 16-bit addressing will be required. So the first advantage is that it is going to allow to fetch the memory of the capacity of 1 megabyte, even though the address which is associated with each instruction will be of only 16-bit. And that is what I have explained, that we are using two 16-bit addresses to generate a 20-bit address to fetch 1 megabyte of the memory. It is going to allow codes, datas, strings, stacks not to be more than 64 kilobyte long, because whenever we write codes, it cannot be more than 64 kilobyte. So it is good to use it in the segmentation form. So it is going to allow code, datas, etc. to be more than 64 kilobyte long using more than one segment. If it is so, if the number of instructions, the number of the datas which are available are more than 64 kilobyte, then in that case, we can use two segments to store that. Now, the best part of the doing memory segmentation is to facilitate the use of separate memory areas for the code, data, and the stack so that they are not getting mixed. Whenever we have to write code, it will be written in a separate segment. Whenever we have to write data, it will be written in certain segment. Whenever we have to use stack, we will be using separate segment. So intermingling of the code with the data or the stack is not possible because they are placed, stored, and work in different segments. And the fourth important point related with the advantage is the relocation, identification, and the retrieval is more easy and useful in case of multi-programming. I have already given an example of multi-programming that it can work in a multi-programming fashion. 8086 can work it. Suppose there are 3 users which are connected with the same processor. So what it will do, it will allow separate code segment for the user number 1, separate data segment for the user number 1, and separate extra segment for the user number 1, separate stack segment for the user number 1. And similarly, it can separate it for user number 2. It will have its own code segment. It will have its own data segment. So what happens whenever the processor is going to switch from one user to another user? It has not to work too much because the relocation can be done very easily from one user to another user, because one user number 1 has been allotted separate space to put their data segment and the stack and the extra. Similarly, user number 2 have been allotted separate space in the memory, so that the user number 1 program is not going to intermingle with the user number 2 program, or user number 2 data is not going to be mixed with the user number 3 data. Why? Because every user has been allotted separate memory space to use as a code segment to store the codes, data segment to store the data, stack segment to use as a stack, and the extra segment to use as an extra data arrangement. So these are the 4 important points, advantageous point of doing the memory segmentation. Besides having advantages, there are certain disadvantages also. The first disadvantage is we are using 1 megabyte of the memory. We are using 20-bit of the address to locate an individual memory location. And still we are using only 16-bit address. We are using only 16-bit register to store the address. So what you have to do, we have to manipulate the address before we are going to fetch any memory or the input output device. So this is the first disadvantage. In case of 8085, you have seen that we are using same space, memory space for storing the code as well as the data. And here we are separating the data from the code. The third disadvantage is it is going to allow to store the program and data separate. So one time, whenever it has to fetch the instruction, it will go to the code segment. When it has to fetch the data, it has to go to the data segment. So it means every time it has to relocate the address relocate where the data is, where the code is. So these are the three disadvantages of the memory segmentation. Then we have addressing modes.